So infinite solutions, just like we saw, it means the equation will be true for any value you replace x with. It's always true. And again, we see that when one side of the equation matches the other side. And that's kind of earlier in the problem. That may take some time to get used to. It's also going to happen if we see 0x equals 0 after solving the equation as much as we can. Once you see 0x equals 0, you just know that there are going to be infinite solutions. If there were no solutions, this means that you couldn't replace x with anything and get a true statement. It will always be false. Okay, so this usually shows one number equals a different number. Or what you may see usually is something like 0x equals anything but 0, right? And again, the reason why this is going to be no solutions is because what can you multiply by 0 and get not 0? You can't do it with any number, okay? So mathematically, we say that's impossible for now. So we just say, in that case, that there are no solutions. So as of right now, from the equations we've solved, we can't have one solution. It's possible to have infinite solutions or no solutions, but do be aware in mathematics we can force there to be 2 solutions or 3 or 4 and so forth. But for now, we're just focused on these 3, 1, infinite, and none solutions. So let's see what happens here. Okay, so we got some distribution definitely because I see these parentheses. Okay, we got 2 sets of parentheses. Let's do one at a time. Here I'm going to be distributing in -1. So that'd be -1 groups of -6x's. That's positive 6x's. But also I got -1 groups of 7, which would be -7. And this should equal, let's distribute this -2. So that's -2 groups of -3x's, which is positive 6x's. And then we have -2 groups of 4, which is -8. Now, this is kind of matching right here, but it's just the x's that are matching. We got -7 here, we got -8 there. So you could make the conclusion at this point, but again, we just don't have the experience to do that yet. So let's keep going. So there's no more distribution, no more combined like terms. I'm now using principles of equality. I'm going to keep my x's on the left, numbers on the right. And if I haven't said this yet, you can switch these. I just always like to have the x's on the left. So at this point, I see this -7 on the x side of the line. No good. I don't want it there. So I will zero it out, and that will allow me to get rid of it. So add 7. I just need to do it on both sides. So drop my 6x. -7 plus 7 is 0 as planned. And then this will equal, I can drop this 6x as well. -8 plus 7 is -1. Now I've got this 6x on the number side of things, and that's no good either. So I will have to zero out that 6x in the red on the right. So that's going to be subtract 6x from both sides. Now again, just like I said in that last problem we did, is I got my x's on the left, so I need to show how many x's this is going to result in, and 6 minus 6 is 0. I need to show that, okay? On the right side though, since that's the number side of things, I don't actually want to show this one, so that's why I'm zeroing it out right there. Now I can drop my -1, and now I can see a kind of a new problem right here, which we talked about in that last slide. But again, it becomes an equation. What value can you multiply 0 by to get a -1? Well, there is no value you can do that with. So what I'm trying to say here is that this one has no solutions. Okay, and we'll just box that in. Again, this is really telling us no matter what value you replace x with, the equation is always false. Once you get a little bit more experience, you probably could have told up here, because you have the x's that match, but then the numbers don't. And then you could say, well, even at this point, right, how can 6x plus nothing equals 6x minus something? It can never happen. So whether you notice here that the x's match and the constants don't, or here, doesn't really matter, or even here at the end, as long as you understand there's no solutions.